Okay, which of the following you are able to find the total distance traveled? Can you find the total distance traveled for the first one? Can you find the total distance traveled for the first one? You learned this in high school, correct? Velocity is the rate of change of displacement, right? Area bounded by the curve of displacement represent what? Rate of change of displacement represent displacement, am I right? So that means why we need to learn integration? Because you want to estimate the area. You want to find the area. Okay, for the first one, you can find the area. Okay, for the first one, you can find the total distance traveled. So what is the total distance traveled for the first one? Yes, Hao Xuan. Who is Hao Xuan here? No. Jian Hao. Hao Zhe. Hao Zhe. How do you get the total distance traveled for the first one? So you find the area bounded by the curve. So first 3 seconds, correct? You got the rectangle, am I right? Because if you find the area bounded by the curve, the y-axis is ds over dt. So it's s over t times t, correct? The area of the rectangle. So what do you get? You get the total distance traveled. Am I right? Hello? So you see, the area bounded by the rate of change of a function give you the total of that. This is rate of change of displacement, velocity. So that's why the area bounded by the curve of displacement give you total displacement. So the first one you can find because it's a rectangle. You know how to find the area of a rectangle. Am I right? So what is the answer for the first one? How do you get 21? Yes. So 3 times 7. So you get 21 meter. Okay, how about the second one? How about the second one? Anyone got the problem with the first one? It's a rectangle. This is 7. This is 3. I didn't draw to scale, okay? So 7 times 3, 21. How about the second one? Yes? Oh, sorry. In the first 5 seconds. Yeah, so 5. So this is 5. Hello, young man. First 5 seconds. Okay, so 5 times 7, 35. Never mind, we can do the correction. So how about the second one? How about the second one? What do you think? How to do for the second one? Can you find the total distance traveled? It's the area bounded by the curve. But you have to know that this particle, correct, at first, it is moving to the right, all right? Starting with a velocity of 3 meters per second. Then after that, it stopped at 2 seconds. Am I right? So after it stopped at 2 seconds here, then it continued to move to the left or right. Left or right after 2 seconds. Yes, left. Why left? Why left? Why left? Is it because it changed direction? In what way this graph tell you it changed direction? Huh?
The figure is negative.
Yes, because the velocity is negative after 2 seconds below the t-axis. Am I right? So that means if I talk about motion diagram for part 2, it will be like that. I don't know where is it on the motion diagram, but I know that at first it's moving to the right. Maybe it is at the left, I also don't know. So it moved from, maybe it moved from here, it go to the right, then it stop here at 2 seconds. How far is it away? I also don't know. But this will be the distance traveled. So this distance will be area here. Okay. Then after 2 seconds to 5 seconds, it moves the other way around. It change direction, it moves the other way around, correct? And this is the area under the curve here. And because it's a straight line, you got 2 rectangles, am I right? You sum up the 2 rectangles, you got the total distance traveled, am I right? So, do you know what is the velocity when t equal to 5? Can you guess what is the velocity when t equal to 5? Because it decreased linearly. So what is the velocity when t equal to 5? 2 second velocity drop by 3. So 1 second the velocity drop by how much? You look at here, 2 seconds. In the first 2 seconds, okay, it starts from 3 meters per second as t equal to 0. Then it dropped to 0 at t equal to 2, linearly, correct? That means I can conclude here, 1 second, each second, the velocity dropped by how much? 1.5, correct? So therefore, t equal to 5, what is the velocity? 0 minus, from 2 to 5 is how many seconds? 3 seconds. So minus 1.5 times 3. So this is negative 4.5. Am I right? So you don't have to find the equation of the velocity. You can use your ratio to get the answer. So sometimes when you do maths, right, you go to simple one. You don't go in such a way that it make it so complicated. Hello? Okay. So can you find the total distance traveled for this situation? Yes? Okay. Quickly find. I will ask for the answer. Hurry up. Yes? Young lady, what are you doing? Yes? What is the answer? Area A, how you get area A, how to get area B? Is that correct? So what should the unit of measurement be? What is the unit of measurement for total distance traveled for this case? Meter, please write down. Okay, thank you. Hello? So anyone got problem with that? Correct? So this one you can. So how about the third one now? Am I going too fast? Okay. How about the third one? Whereby and I put a knob here. I go down like that. And your VT is 1 over T. Okay. In 5 seconds, first 5 seconds, can you find the total distance traveled? Can you find the area bounded by this curve? Cannot. So if cannot, then what should I do? Can I estimate? Can I estimate? Is it possible for me to estimate? Okay, to make our life easy, can I change this function to +1? T plus 1. Can I not? T plus 1. So that 0 is involved, so that you know what to do. Yeah. If I put T, then T cannot be 0. Am I right? So can I put T greater than 0? T plus 1 instead of T. So just change. The graph will be the same as well. Okay? Okay, so now, can you make an estimation? Definitely it's a curve. It's a curve. It's a curve, correct? It's a curve. Definitely you cannot find the exact total distance traveled in the first 5 seconds. Then what should I do? I want to estimate. So how to estimate? What will you do to estimate? Okay, who can give me an estimation? Okay, who can give me an estimation? Who would like to give me an estimation of the total distance traveled by this particle in the first 5 seconds? Give me a value. Okay, those who are online. Ian, Aiman. Give me an estimation, please, for this case. Ian? Ian?
Yeah.
Yeah, what is the estimation that you will give me? Give me a value. Just give me a value. Yes?
Like 4.
4. Okay, how do you get 4?
It's an
How
estimation.
do you make this estimation? Yeah, when we talk about max. Okay, when we talk about max, you must tell people how you estimate. If not, we will just say you simply give me a value. They must have an evidence that how do you estimate? Okay, you say he estimate 4 meters. So Ian, Aiman, I ask you, is this an overestimate or underestimate of the area of the shaded region?
Over.
Over. How you know it's over?
Because the max velocity is 1.
Okay, the maximum velocity is 1. I follow whatever you say. Then,
And then it decreases afterwards.
yeah, it decreases afterward, but how you get the value of 4 and not 5? And you say this is an overestimate, huh? Why you say 4 and not 5? Now I ask you this question, you must be able to answer me. Correct? Why you choose 4 and not 5? For me, I will choose 5. Do you know why? Because I'm going to draw this rectangle. Then I can prove to people this is overestimate, the red one. So 1 times 5. So 5 meter is the overestimate. Correct? I have a proof. Am I right? The red area is definitely greater than the blue area. So Ian, Ayman, how do you get 4?
Cut it in half.
Cut it into half.
Yeah.
How do you cut it into half?
The rectangle.
Can you annotate?
No, I can't. I can't annotate.
You can't. Okay, so you see, you say cut it into half. You can show me how you cut it into half. So you see, you can have an overestimate. Can I have an underestimate? Can I have an underestimate? Can I use an underestimate? Can I have an underestimate? Can or not? Possible to have an underestimate? I can use this rectangle as an underestimate. So this rectangle, the point for this one will be what? 5 and what is the velocity when t equal to 5? What is the velocity when after 5 seconds? Vt is 1 over t plus 1. So what is the velocity after 5 seconds? Yes, who are you? Ashwinder. Yeah. So can you tell me, so what is the velocity when t equal to 5? Yeah, 1 over 6. All right. So it's 1 over 6. So I will get an underestimate which is 5 times 1 over 6. So which is 5 over 6 meter. All right. But you see whether it's the overestimate or the underestimate is way far away from the actual value. Am I right? Is far away from the actual value. Am I right? So what else can you think of to give a better approximation in this situation? How? How to give a better approximation? Anyone? So my iPad is going to go to someone. You give me a better approximation. So can you draw? Can you find another shape whereby that is possible for you to find the area and you will give you a better approximation? Yes, young man. Your name, please?
Sebastian.
Sebastian, okay. Use different color. It's exactly the first one, young man.
I know, I draw a triangle. Then
Okay. So Sebastian draw a triangle. So this triangle, Sebastian, is it underestimate or overestimate? So you have to decide. So 2.5 is under or over. He's talking about from 1, you go to 5. Correct? So are you sure this is over? Are you sure this area, which is not covered, is bigger than this area? This area, this blue area, which area is bigger? Blue area or green area? You can't judge unless, you can't judge unless you draw accurately. Correct? So in this case, 2.5, in this case, I cannot judge whether it's an overestimate or underestimate. But I can do another better approximation whereby it's an overestimate by drawing another shape. So I'm going to pass the things to your class who is attempt physically. Overestimate. I want to get a better overestimate. A particular shape whereby you know definitely is an overestimate. It's a, okay, give you the hint, trapezium. Trapezium. Trapezium, trapezium. Do you know what is a trapezium? From the point 1, go join to the point 5 and 1/6 using a straight line. You don't know trapezium in exam, I come up. Okay, let me do it. Okay, you can draw a trapezium. So isn't it this will be a better approximation compared to just now the rectangle? Isn't this is a better approximation? Yes, it's a better over approximation. It's nearer to the actual one. The only difference is the area bounded by the curve and the straight line. Am I right? So how to find the area of a trapezium? How to find the area of a trapezium? How to find the area of a trapezium? I'm going to send you all to the primary school. Now how to find the area of the trapezium? Half sum of the parallel side times by the length. All right? Okay. So this is another way to make an approximation. Okay, so there are many ways to make approximation. So depend on which way you want to use it. Okay, but we are going to learn another way of doing it whereby it gives us the sense of the word integration. Okay, so now let's compare. For this situation, now let me draw. If I ask you for this situation, for t greater than 0, less than 5, divide into two rectangles of equal width. How will you do it? Divide into two. Okay, I put upper rectangle. After I explain the upper rectangles of equal width. So what does that mean? Is it important for me to say the word equal width? This is something that you have to take notes of. So now, if I divide this into two rectangles of equal width, so first of all, I have to know the width of the rectangles first. So how to get the width of the rectangle? How to get the width of the rectangle? How am I going to get the width of the rectangle? Our rectangle is going to stand up like that. So this is called the width. If you don't know what is width. So how am I going to know the width of the rectangle? Okay, why 5 divided by 2?
Because it has equal width.
Yeah, equal width. Because I got two rectangles. So it's 5. I start from 0. So I take 5 minus 0. So this is called the first 5 seconds. So this is the, okay, divide by 2 because I use 2 rectangles. And because of equal width, that's why you divide by 2 so that every rectangle will have the same width. So the width will be 2.5. Okay, so now when you talk about upper rectangle, so when you mark down 2.5, okay, so now the two rectangles. So for the first rectangle, because I want upper rectangle, so upper means the height must be taller. So which should be the height at t equal to 0 or t equal to 2.5? This one definitely is taller, correct? Yeah, so it doesn't matter whether left or right. There are two sides of the rectangle. So you have to look at the two sides. The taller one will make the height of the upper rectangle. So I draw the first upper rectangle. Am I right? Then for the second one, is between 2.5 to 5. So you have to check also. Sometimes it can change because the curve can change direction. So 2.5, the y is bigger, am I right? So that is another upper rectangle. So now, this will be a better overestimate compared to just now we only use one rectangle, am I right? So, am I right? So the estimation is much better now. So now I have to find the area of the two rectangles. So now everyone take out your graphic calculator. Key in your y1 as 1 over 1 plus x. Those online, you better key in. Okay. So key in already, quick from there. I unmute myself, the other one. Okay, so you key in idea, right? So you want to find the total distance, you want to estimate the area, correct? So what you can do is, you can write down, okay, what you can do is, okay, you can write down in this way, listen here. You can say your Y1 is VT, okay, can or not? You write down in your, in exam, you just do like that. So therefore, total distance travel over estimate of total distance travel in the first 5 seconds is equal to, what is the width? So when you want to find the area of a rectangle is width times height, am I right? So since it is equal width, we write down the width 2.5. And the first one, the height is when t equal to 0, am I right? So you just put y10 plus the second one is when t equal to 2.5, correct? So you put y1 2.5. Okay, then answer. So Sebastian, you're supposed to give me the answer because you use my calculator. Great. Those who are in the class, if you don't know how to use your calculator, you better let me know. You got 3.214 meter. So that means during the exam, correct? As long as you write this and you write down like that, you don't have to count exact value unless the question says exact value, then only we substitute in. But usually when you talk about overestimate and underestimate, we will not ask you for exact value because it's an estimation. Do you get me? So now, this is so much nearer to the actual one, correct? Compared to when we use one rectangle. Yeah? Okay, so now I want you to use the same method, make an overestimation by using 5 rectangles of equal width. Can you all please start? Same question. Using 5 rectangles of equal width to make an overestimate of the total distance traveled in the first 5 seconds. So you have to determine the width first. Yeah. Then draw the upper rectangles. Then key into your, write down the formula that you key into your calculator. Then use your Calc GC and get the answer. Also calculate. The first rectangle, the height is y10. The second rectangle is y11. All right. And the third rectangle is y12. The fourth rectangle is y13. And the fifth rectangle is y14. You can just keep calling out and get the answer. So what is your answer? 2.28. So you get 2.28 meter. So your answer should be less than this because it's a better approximation. It goes nearer to the actual one. Hello? Are you okay?
Why is this better for overestimation?
Hmm?
Why is it better? I thought it's overestimation.
Yeah, but it's compared to two rectangles of equal width. Compared to two rectangles of equal width, it is a better approximation. Yes, that is given. 2.28 meter. So are you clear? Okay, now I want you to look at the same situation to give me an underestimate for this situation. What is the underestimate? Can you give me an underestimate? By drawing lower rectangle. Do you know how to draw the lower rectangle for this case? So you can draw a graph by yourself. Get a lower rectangle, please. Do you know the meaning of lower rectangle? So this is the sum of 5 lower rectangles. Sum of 5 area of lower rectangles. So the lower rectangles, the situation will be like that. The first rectangle is here at 1. The height is 1. So you are using this point 1, y1, 1. And it continues. So am I going to retype everything in the graphic calculator? So young people, if you are smart enough, you know how to use your graphic calculator from here. You put second enter. You change the 0 to 5. Because I want it to be from 1 to, you change the 0 to 5. And the last one is y15. So I just change the 0 to 5. I will get the underestimate. Am I right? So what is the value of the underestimate then? You put second enter. Yeah. Yeah. Okay. So 1.417. $1.417. Do you get that? Do you get 1.417 or no? What should be the answer? 1.45. Do you get 1.4? 417 or 45? Huh? You cannot get it from here. You don't know how to get it from here.
I do.
Okay, 1.45. Do you get 1.45?
Oh no.
1.45. Okay, 1.45. Okay. Hello. Young man. Where got people do like that? What you need to do is you just put 1, open bracket, second y1, you put 1, then plus. What are you doing?
Oh, I know. I just.
Then do. You go and find out y1, y2, y3, 1 by 1, then use scientific calculator and do it. How can? Okay? Got it? Hello. Okay, now, Mr. want to ask you a question. Can I make use of these two and make a very good estimation of the area bounded by the curve? One is over, one is under. So can I make a much better approximation that is very close to the exact one by using these two values? The over and the under estimate. Can I?
Midpoint.
Yeah. Find the
Midpoint.
midpoint.
The mid
The-
value. Mid value.
Okay. Other than say mid value, what is another word?
Average value.
Yes, you can find the average of underestimate and overestimate, then you will get the exact value. Average. Underestimate and overestimate. So you get, just how our underestimate is, you see, we still have to go back. Over is 3.214. $3.214 plus under is Oh, 2.28, 1.415. 2.28, 1.415. Two 2.28, 1.415. I divide by 2. What do you get?
Means something the answer is 1.44.
1.45. Okay, sorry. Then what is the answer? 1.865. So that goes very close to the actual one. One is over, one is under. You take the average, you get close to the actual one. Okay, so if we want to get the exact value of the area bounded by this curve, okay, let me finish this first. Tomorrow I will continue. If I want to get the exact area bounded by this curve, I can use my GC. Everyone take out your GC. Take out your GC. Yeah. Go to math. Go down. Go to FNINT. Do you have FNINT? Select that, please. Select FNINT. Okay, you got that? Okay, so this sign will come out. This sign will come out. Am I right? So the lower limit is 0. The upper is 5. Type in. Your function is y1. Then you put dx. Then put enter. May I know what is the answer?
1.79.
Yeah. This one gives us the answer 1.7. 792, which is very close to our average. Am I right? So tomorrow I will continue with this one to tell you the meaning of integration. The meaning of integration. Why integration they take this shape? Who can tell me? Why integration take this shape? Just how when we talk about one rectangle, we talk about two rectangles, we talk about 5 rectangles, correct? What are we doing? We find the what? The what? The what? There's one word on the board there in blue. One word in blue. And the shape, the first alphabet of the word is almost the same as the integration sign. Do you see that? Which word is that? See that? See that? Sum. So anytime you want to do summation, so integration carry the meaning of the word summation. So how are we going to come to this summation? So tomorrow I will explain. Or you read your book and you try to understand it. Chapter 4. Okay? So I will end the class now. Oh, you overshot. You see, there is a problem with physical. I can overshot. Okay, so I will see you tomorrow. Thank you, class.
Thank you, Miss.
Thank you, Miss.
Thank you, Miss.
Thanks, Miss.
Yeah.